All right, how about this one? What if we, let's take a look at an example here where, what if we had, I gave you this problem. I told you that the volume of this rectangular prism, so it's just, it's a kind of a box, is 1,200. We don't even care about the units, 1,200. The width is 12, the depth is 9, but we don't know the height. That's what we're trying to find. How could I do that? Okay, so we know the formula for volume would just be the product of all the dimensions is 1,200, right? So we get, we get 12 times 9 times h equals 1,200, right? Now what? Okay, multiply 12 and 9, be 108. So 108 h equals 1,200. Last step? Divide by 108. Okay, so we got it. So we know then that h equals 1,200 over 108, right?
Right.
And we could simplify that probably, couldn't we, I suppose? But let's just divide it out. Okay, that's what I really want to get at here, is let's actually do that problem. Let's divide that out and see what we get. Okay, we're not just going to leave it as a fraction. We're going to try to write it as a mixed number. Now, we don't like mixed numbers. We would never do that anymore, but let's just take a stroll down memory lane and let's write it as a mixed number. Cole, put that away, please.
Sorry.
So let's figure out what we get. Now, if I want to divide that out using long division, what's it look like? Okay, I got to make my division bracket, right? What goes where? Okay, the 108, whatever's in the denominator goes out front, right? Good. Whatever's in the numerator goes inside. Now, talk to me about what happens next. So does 108 go into 1? No. So I got to scoot over another digit, right? Does it go into 12? No. Does it go into 120? Okay, so finally we get if we go over 3 digits, we get a number that 108 goes into evenly, right? 108 goes into 120 how many times? 1. Okay, so I'm going to, what do I do then? Before I subtract, I got to do something else. You remember this? It's been a while, hasn't it? You're going to multiply, right? 1 times 108 is 108, and then I subtract. Okay, is that ringing a bell?
Yeah.
So 120 minus 108 is what? 12. Okay, but 108 obviously doesn't go into 12, so I got to drop another 0 down, just drop another digit down, right? And I get 120 again. Well, we already did this, right? 108 goes into 120. We already know it goes in 1 time. But if I distribute that again, I'm going to get a 108. And when I subtract, what do I get? 12. Okay, well, I'm done, right? Now I can't, there's no more digits to drop, and I don't want to write this as a decimal. I want to write an exact answer, which means I want to have a fraction, okay? So what did we call that piece at the end of the division process when I couldn't go any further? What did I call that? The remainder. That was the remainder. Okay, so let's think about what the remainder is, right? Here, everybody say this, because this, everyone always wants to know. You remember way back like in grade school, you would have probably written this as 11R12. What's R12? Doesn't mean anything, right? R12 by itself is meaningless, right? Yeah, the remainder is 12, but we got to do something with that. So everybody say this out loud. You only say it once, and then you're going to repeat this, because you just got. I really want you to remember this. And I get this question 1,000 times, because people haven't done this in a while. The remainder is what remains over the denominator. Altogether, the remainder. There you go. Okay, now you got it, right? So when you say the remainder, what you're thinking about is it's what remains over the denominator. It's what didn't go away. It's still going to be stuck as a fraction with the denominator. So our answer then, if we wanted to simplify this, okay, our answer looks like. Everybody with me? Okay, so here's what we're going to get. We got the integer, whoops, wrong color. We got the integer 11 right?
Right.
Plus, we had some stuff left over. What remained over the denominator? 12 did. So it's 11 plus 12 108s. Now, if we were using mixed numbers, we just write that as 11 and 12 108s, right? We don't do that anymore. We abandoned that probably like 6th grade, if not earlier. We don't want to do that anymore. But if I did write this with mixed numbers, I'd write it like that. And I could reduce that fraction, but I'm not going to bother. Okay? Make sense? Okay, so now let's apply that. Well, let's maybe do one more, just to get a little more practice. So let's divide this one out. How many times does 3 go into 178? So what goes first? 3 goes into 17 5 times. If I multiply that through, what do I get? Okay, and I'm going to subtract. Okay, 17 minus 15? 2. Now what? Drop the 8. 3 goes into 28 9 times. 9 times 3 is, and what do I get? And that's my remainder, isn't it, right? So the answer is 178 over 3 equals 59 plus what? 1 over 3. Okay, that's it. No big deal. So now, the goal for today. Today we're gonna do the same process, but with polynomials. Okay? But they're the same steps. So here's one of those times when you gotta just, okay, this is like 4th quarter, last drive of the game, you gotta really focus. You can coast for part of the game, but now you gotta go hard. Now you gotta really focus here for 5 minutes, really hard, and you're gonna get this, and then you can practice it, and you're done. Then you got it, and you put it away in your brain, and you can feel good about it. We're going to test over this, and you'll have it figured out. It's really not an extremely hard process, but you have to have some perseverance because there are a number of steps to it. So you need a second to psych yourself up here mentally. Can you do this? Can we do this? Okay. All right. So how do I write this then? We've got a fraction, just like before. If I'm dividing polynomials, okay, what goes where? Top goes inside. Good. Okay, top goes inside. And what goes outside? Good. So the x minus 1 goes outside, the top goes inside. Okay, but let's think ahead here a little bit. So, hey, I feel like some of you guys in the back want to come forward. Can you get in the back there, get there? I think you should. I really think you should. This is one of those times when it would make sense.
Oh, yeah.
I would.
Right in the center.
Crazy not to. There you go. You guys are good, you think?
Good, everybody.
Okay.
Yeah, boys. Front and center.
Okay, once again, I'll invite everybody to put those phones away. If they're out, they're going to distract you. Hey, ladies, let's put our phones away. Pockets. Keep that in your pocket. Let's get it out of the way. Otherwise, it'll tempt you.
You good, Connor?
Uh-oh.
Sawdust. You get sawdust.
Okay, here we go. Back to business. Here we go. Okay, let's think back to the experience we had when we multiplied out polynomials, right? When we multiplied polynomials, we had to add up a bunch of like terms, right? With numbers, that's easy to do, but with polynomials, when we're adding and subtracting stuff, we want to make sure that we're lining up the like terms vertically so we can make the addition and subtraction process a lot easier, right? So we got to be careful. When we put this polynomial on top, inside, I don't want to write it out the way it is. I want to make sure that I'm going to leave a column for every power of x, because when I go through that long division process and I'm subtracting vertically, I got to make sure that all of the powers of x line up, right? So that's a crucial step. You can't forget that, or this becomes really difficult, and you're almost certainly going to get the problem wrong if you don't do that. So this stuff, when I put that inside, oh, you can't see that, can you? How's that? So when that goes inside,
What color is that?
I kind of like green. So when I put that inside, I'm going to start with my x cubed column, then I've got a minus 8x squared. Well, what comes next? I gotta keep a column for x. Even though there's no x term up here, I gotta make sure I have one for later when I'm doing my subtraction. So I've gotta put a 0x there, right? Okay, we wouldn't normally write that. 0 times anything is 0, but we gotta leave a place for it. And then finally, we get our plus 11, okay? Now, we gotta ask ourselves, okay, how many times does x minus 1 go into this thing? Well, that looks complicated, but all we have to focus on are the leading terms. That's it. So we want to ask ourselves, how many times does x divide into 3x cubed? Well, let's find out. 3x cubed divided by x is what by our properties of exponents? X cubed divided by x is, that's x to the 1. What do I do if I divide like bases?
Subtract.
Subtract.
Yeah,
So I'm going to get 3x squared. Okay, so that is the first term in my answer, okay? So whenever I get a term up here in my answer, I'm just going to do what I do with long division. I'm going to multiply it by what's out front. Okay, same as before. When I got a number up here, I multiplied first, right? So 3x squared times x is 3x cubed, right? 3x squared times minus 1 is minus 3x squared, right? And then here's another part that's important. I'm going to put this whole thing in parentheses and put a minus sign out front because I'm going to subtract vertically, but when you subtract polynomials, you got to make sure you're always subtracting each term. So here's what you should even do on your paper. Do this on your paper until you get good at this. You're going to tap right there and say 3x cubed minus 3x cubed is what? 0. Okay, it has to be that way. The first term, that's why we picked 3x squared to be our first term, is so that the first terms would cancel out when I subtracted. That's the whole point of this process. Colton, you're not getting any of this. Why don't you turn around so your feet are facing forward? I feel like you're missing a lot of this. I'll wait for it. Thank you. Okay, so I'm going to subtract those, and those first terms would have to go away, right? And you'll see why that's important, because we're gradually going to kind of whittle away at this thing where it's going to get smaller every time. And eventually we can't do this process anymore, right? So those cancel. Okay, they're gone. They cancel away. Now, what do I get when I subtract negative 8x squared minus negative 3x squared? Subtracting a negative is the same as what? Add it. So what's negative 8x squared plus 3x squared? Negative 5x squared. Okay, and then I just drop all this stuff straight down, just like I do with regular long division. Now I start over. Okay. So now I got to divide x into negative 5x squared, right? So what is negative 5x squared divided by x? Negative 5x, right? Good. And so that becomes the next term of my answer. What do I do when I get a number up here, or in this case a term? Multiply, right? I multiply out front. Okay. So negative 5x times x is negative 5x squared. And what do you know? Those will always be the same because we subtract, they've got to cancel. Negative 5x times negative 1. Negative 5x times negative 1.
5x.
5x. Okay, and we're going to subtract. I'm going to put the whole thing in parentheses and subtraction sign out front. So negative 5x squared minus negative 5x squared, well, of course, those are going to cancel, right? What's 0 minus 5x? Negative 5x. And then I bring down the 11, and I start over. And I just keep going until I'm done. So now I want to know how many times does x divide into negative 5x? Well, let's find out. Negative 5x divided by x is what? Negative 5. The x's just cancel, right? And so that becomes next term. Okay, now this is going to be the last one though, right? Because when I get a constant up there, I know I'm not going to be able to do this anymore. Next time I try to divide, I'm not going to be able to, I'm going to be trying to divide x into something that doesn't have any x's in it. You'll see it happen. But I know when I get to the constant, that's the last term in my answer, the polynomial part of my answer, the regular part of my still have to do the remainder part, but we're done with the regular part, okay? If I distribute that through, negative 5 times x is negative 5x. Negative 5 times negative 1 is plus 5. And now I'm going to subtract. And what do I get? Well, cancels. 11 minus 5 is 6, and I'm done, right? Because now I can't divide x into 6 anymore. So what's that? What must that be?
Remainder.
The remainder. Okay, what does the remainder do? It's what remains over the denominator, right? So when we write out this answer then, look at the parts we get. Well, we get this part, we get the polynomial part. So my answer is equal to 3x squared minus 5x minus 5 plus what remains over my denominator. My denominator is x minus 1. What remains over the denominator? 6. Okay, so that is our answer. Okay, compare that to what we got when we did regular long division. We got an integer plus a fraction, something remained over the denominator. When we do polynomials, divide polynomials, we get a polynomial plus something remains over the denominator, right? Let's do one more. That's the process there. You can do that, you got it. Okay, how about this one? It looks harder, doesn't it? Bigger polynomials. It's going to go faster though, we'll see. Okay, so what goes where? I got to make my bracket. What goes where? Top goes in. Okay, so let's write, the top is going to be, tell me what to write. 4x to the 4th plus x cubed, 6x squared. Not done. Not done though. 0x, I got to have a column for x, and I got to have a column for the constant. Got to have a column for each power of x. Well, there's x to the 4th, x cubed is that column, x squared is that column, x to the 1, x to the 0 is the constant, right? Outside, we've got whatever's on the bottom. Okay, and now we just have to figure out how many times does, what is 4x to the 4th divided by 4x cubed? Well, the 4's cancel. X to the 4th over x cubed is what? So x is the first term. If I distribute that through, what do I get? That's easy. If I multiply something by x, what am I just doing to all the powers? Making them one bigger. Good. So I'm just going to get 4x to the 4th plus x cubed plus 3x squared plus 5x, and I'm going to subtract the whole thing. And what do I get? Well, those cancel. X cubed minus x cubed, those cancel, right? Over here, finally, I get 6x squared minus 3x squared is what? 3x squared. 0 minus 5x is minus 5x and then nothing there, right? Okay, what about now? Can I do 3x squared divided by 4x cubed? Doesn't work, right? Because this is a smaller power of x than that is. When I try to do 3x squared divided by 4x cubed, doesn't work. So that means this is what? The remainder, right? If I can't divide anymore, it doesn't work, then that's the remainder. What I'm left with is the remainder. The division process has stopped, right? So that was pretty quick. So my answer then looks like, I only got one thing in my polynomial, just one term. I got an x plus something that remained over my denominator. Well, there's my denominator. And what remained there? 3x squared minus 5x. So that's my answer. Make sense? Okay. Go. 4 problems. That's all you got on that assignment.